Moving on to the
conference will now be
first
recorded.
topic, known as filtration and clarification. Any idea what do you mean by filtration? First, anyone? Say I expect the class to be interactive. If you know, go ahead. If you do not know, no problem. At least give a try as what you know so that I can elaborate on. Yes, anybody? What do you mean by filtration?
Solid particles are separated from the liquid form.
Okay, good. Then anything else? Anything you know about filtration you can talk. Anything about filtration? As she said, other than that? Okay. So in general, filtration is nothing but, so in general, the topic we are going to cover is introduction, mechanism of filtration, factors affecting rate of filtration, what do you mean by filter media and what are the filter medias we are going to use, what are filter aids, what are its uses, filtration equipments. So these are covered under filtration and clarification chapter. Okay, moving on to first the definition as I was talking. So filtration in generally is nothing but separation of solid from fluid by means of porous medium. That is, there is a medium in between so as to differentiate or to separate them as such. Okay, that retains the solid but allows the fluid to pass through. That is, in general, you'll have a mixture of solid and liquid. Okay, so your main concern is to separate the solid from the liquid. Okay, so how do you separate is by means of a material known as filter media, or in general any porous medium. Okay, so whatever solids are there, they go and retain over the surface of this porous medium, and whatever liquid are there, they just flow down. So by which what happens is that whatever solids are there which we are intending to separate from the liquid, they stay over the surface of this porous medium, leaving behind the fluid separately or the liquid separately. Clear? This is nothing but the filtration. So the separation of solid from the fluid by means of a porous medium. So this porous medium acts like a filtering medium, okay, which helps in retaining the solid as such and allowing the liquid to pass through it. Is that clear? That is filtration. Then one more term, we call it as clarification. So clarification term we use whenever in the liquid whichever we are thinking of separating, it does not have more than 1% of solid in it. It does not have more than 1% solid in it, and whatever filtrate is there, that is the primary product. What do you mean by filtrate? Any idea what do you mean by filtrate? The term filtrate?
The liquid which has passed through a filter.
Right. So whatever the mixture we had of solid and liquid, whatever has come through the filter media or porous medium, whatever we are going to get the liquid, we are going to call it as filtrate. So if filtrate is the primary product which we are intending to out of the mixture, if it has solid and liquid, the mixture in which the solid concentration is very less, not more than 1%, but our main intention is to get the filtrate, that is liquid. So that process we call it as clarification. Okay, then we have something known as cake filtration. So it is similar to filtration, but we are intending, or our intention is to obtain the cake. What is the cake? It is not the edible thing what you eat. In general, cake is nothing but the form of the solid which has already formed on the porous medium. Any solid which goes and stays or adheres over the surface of this porous medium forms a cake or a deposit. Okay, that we call it as a cake. So if recovery of solid is desired, the process is called as cake filtration. Generally, what happens in filtration process is you'll have a mixture of solid and liquid, right? So you will pass it through the porous medium and you will get a liquid. Clear? So whatever, and there are different terms for each. We'll talk in the next slide. So whenever our intention is to get the liquid, okay, whenever our intention is to get the liquid out of the mixture, we are going to call the process as clarification. But in that case, we should have solid also in it, not more than 1%. Fine. Not the product, not in the product. I mean, solid should be there in the mixture which we are trying to separate. Fine. So that is clarification. So whenever we are, our main intention is to get solid from the mixture, we are going to call it as cake filtration. So if recovery of solid is desired, the process is called as cake filtration. Any doubt? Anybody?
No, ma'am.
Fine. We'll move ahead. So next, what do you mean by feed or slurry? Okay, in general, feed or slurry is nothing but a mixture of solid and liquid. Okay, slurry is nothing but a mixture of solid and liquid. So that we are going to call it as a suspension. Okay, a suspension is a one wherein we have solid and liquid. Fine. It is not solution. What is a solution? Anybody? There's a difference between suspension and solution. What do you mean by solution? Anyone? What do you mean by solution? Am I audible? What do you mean by solution?
A liquid mixture in which the minor component like
Solution is homogeneous
solute.
mixture of two substances.
Sorry, one by one. Two of you are talking.
A
Yes.
liquid mixture in which the minor component like solute is uniformly distributed.
Okay, good. Then one more. Someone else was answering. A guy was answering. Yes. Who is it? Please answer.
Solution is a homogeneous mixture of two substances.
Right. Okay. So in general, solution is a mixture of solid in liquid. Okay. The solid, whatever we are going to call, we are going to call it as a solute, and liquid we are going to call it as a solvent. It's a mixture of solute in solvent. Whatever solid we are telling, that would have dissolved in the solvent. Clear? For example, best example of a solution, if you take a solute as salt example and solvent as water. So salt, when you dissolve in water, you get solution, salt solution. So here salt becomes the solute and water becomes solvent. Is it clear? That is a solution. When a solid is dissolved in a liquid to get a solution. Fine. Then what is suspension? Anybody? I'm going very slow because it's a first class. So later on we can increase the pace. Okay. Yes. What do you mean by suspension? Any idea? Obviously, there is a difference between solution and a suspension. What is it? Okay, I'll tell you. In general, whenever we say solution, the solid is soluble in the solvent. Okay, always, whenever we say a solution, the solid is soluble in the solvent. When we say suspension, solid is insoluble in the liquid. Okay, solid is insoluble in the liquid, but both are present together. Clear? That is, you'll be able to observe that solid are present as it is in the liquid. For example, for just imagination, I'm telling you, if you have a beaker with water and you add sugar to it and you try to dissolve, does it get dissolved? Please try to answer. So if we take a beaker of water and we add sugar to it and try to dissolve, will the sugar dissolve in water? If yes,
Yes, ma'am.
what does it form? What does it form?
Yes, ma'am.
What does it form? On dissolving, what does it form? sugar on
solution.
dissolving with, yes, it forms a solution, right? Another example, if you take a beaker with water and you try to add sand to it, sand, what happens? You take beaker with water and you add sand to it, what happens?
It will not get dissolved.
It will not get dissolved, as well as the sand will just go and settle in water. Yes or no? Now, in the first case, will you be able to make out that sugar is dissolved in water? If I get you the dissolved solution and ask you whether in this particular beaker what is present, whether it's salt or sugar, until you taste it, will you be able to tell what was present earlier?
No, ma'am.
No, it looks uniform, right? This is solution. You'll not be able to make out that a solute was earlier dissolved in that particular solvent. So that's a solution. Okay, even though two components was there, water and sugar, but ultimately you'll be able to observe only one clear solution. That is solution. Clear liquid it is. Now the second example whichever I gave, water and sand, right? So now sand remains suspended or it will be settled at the bottom. So even after you try to mix it, it will not dissolve. So will you be able to make out that sand was added to water even after some time?
No, ma'am.
No, you'll not be able to make out that sand was added to water or sand was present in water.
No, ma'am.
You will be able to make out. No, you'll be able to see.
Yes, ma'am.
Right. See, sugar, because
Yes,
it got
ma'am.
dissolved, you cannot make out that it was present. Sand,
Because
because
it
it
is
dissolved.
soluble. Yeah.
Exactly. Because sand on adding, even after mixing or whatever you do, it will not get dissolved in water. So if you keep for years together also, you'll be able to observe the sand particles in water. Yes or no?
Yes.
I hope you understood.
Yes,
So
ma'am.
this,
Yes, ma'am.
the second example, whatever I gave, is an example of a suspension. Okay. So this is a common example of what I said. So there are various solids which are insoluble in water. So that can act as a suspension. Best example of commonly uh, available suspension which people remember is, have you heard about gelusil? Gelusil by chance?
Yes, ma'am.
Yes, ma'am. I hear.
What is gelusil? Yes. What do you mean by gelusil?
That is for gastric.
Right.
Yeah.
So, no, that's okay. So that's especially used whenever a person is suffering from acidity problem, right? So the Gelusil product, don't mind, I'm just giving one single example because most of you would have used or seen, right? So that's why I'm giving that example. So Gelusil is an example of a suspension wherein the solid whatever is present in that particular dosage form is insoluble in the liquid. It will be solid as it is because it will not get dissolved in the liquid whatever is being used in gelusil. Clear? So that's an example of a suspension. So what is a slurry? It's a mixture of a solid and liquid wherein solid is not dissolved in a liquid. Fine, because of which solid and liquid you can separate. If there is a solution, you cannot separate solid and liquid. For example, I'll tell you the same sugar solution. If I tell you after the sugar has dissolved in water, separate and give me sugar and water. Can you do it? After dissolving sugar in water, I'll ask you separate out sugar and water separately as it was before. Can you do it? Just
No,
through
No,
No,
ma'am.
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 filtration.
No, ma'am.
You
Ma'am.
can do it, but not through filtration. Okay. If you heat thoroughly the same solution, it will form a solid, but water would have evaporated. Okay. So in general, once solution is formed, you cannot separate solid and liquid. But in case of suspension, since they do not dissolve with each other, you can separate solid and liquid. So what is a feed or a slurry? It's a mixture of solid and liquid from which solid and liquid has to be separated, or the suspension of solid and liquid to be filtered or separated is known as a feed or a slurry. Clear? Clear? What do you mean by solution? What do you mean by suspension? What do you mean by slurry? I hope
Yes,
you're
ma'am.
clear. Nobody has any
Yes,
doubt? Okay.
ma'am.
Moving on to next, filter medium. What is a filter medium in the sense? It's a porous medium used to retain the solids, or in general, it is a medium which helps in separation of solid from liquid, or it helps to separate the slurry. Clear? So filter medium is nothing but a porous medium used to retain the solids. Best example to understand this, the common example is, most of you would drink tea. You would have
Yes,
prepared,
ma'am.
you would
Yes,
have
ma'am.
prepared, right? So whenever we prepare tea, we get decoction as well as we get uh, the solid particles as well, the tea powders as such, right? Whenever we prepare tea, right, we are going to throw away the solid particles, whatever we get. We take up only the decoction part, right? So wherein when we prepare, there would be a mixture of liquid as well as the tea leaves or tea powder as such, right? So tea powder along with milk or other contents, you can call it as a slurry. Don't give this example in exam. It's just for your understanding, I'm telling you. So just imagine the slurry as the tea powder along with milk or the decoction what you get. Filter medium is nothing but the medium what you use for separating, the sieve what you use for separating the tea powder or tea leaves from the liquid. Ultimately you use a filter, right? The chunni you call, the medium what
Yes,
you use
ma'am.
to separate the tea powder from that of the
Yes,
liquid or the decoction. So that's the filter medium, which is a porous medium which is used to retain the solid. So this example whatever I'm giving, the solid is the tea powder. Okay. So first I'll talk about the domestic use, then I'll tell about in pharmacy example for each. Then filter cake. So filter cake is nothing but accumulation of solids on the filter. In the same example, whatever I'm giving, filter cake becomes what? Anybody, if you have understood, what is the filter cake here in the tea example?
The left
Filter
out
cake.
tea powder
Yes, the left
after
out tea
steaming.
powder onto the filter medium is nothing but the filter cake, right? And what is a filtrate? So it is the tea what we get.
yes,
I
ma'am.
hope it's very clear. So
Yes, ma'am.
pharmaceutically now I'll talk. So feed or slurry is nothing but a mixture of a solid and liquid which has to be separated. Fine. Filter medium is nothing but the porous medium. It is similar to same say what we use in household. So it is a porous medium which is used to retain the solid which we are intending to separate. Fine. So this solid will stay over the surface of the porous medium. And what is the filter cake? The same solids which will retain on the porous medium, we call it as a filter cake. Clear? And what is a filtrate? So filtrate is the liquid which is cleared of the solid now. Is it clear? All the definition?
Yes, ma'am.
I hope everybody has understood.
Yes, ma'am.
Yes, ma'am.
Okay, we'll move ahead. Okay, we'll move ahead. Moving on to next very important mechanism of filtration. What is the exact principle for filtration to happen? So in general, the flow of solid is resisted by the filter medium. Now just imagine a setup wherein we have a all of you have you seen this funnel,
Yes, ma'am.
Yes, ma'am.
Ma'am.
right?
Yes, ma'am.
So just imagine a funnel. So inside the funnel we are just going to keep a filter paper. Okay, imagine a funnel. So inside the funnel, we are going to keep the filter paper. Okay. And below this particular funnel and the filter paper, that is below the tip of the, at the tip of the filter, the funnel, we are just going to keep a beaker. Okay. Three things. We're going to have one funnel. We're going to keep a filter paper inside this particular funnel. And the tip of the funnel, we are going to keep the beaker. Fine. So now what we do is that we take a slurry. So what's a slurry? We take a slurry in a beaker. What's a slurry?
The suspension of
The
solid
substance.
to be
Right. A
filtered.
suspension of solid and liquid to be filtered, right? So we take that and we just pass on to the filter paper which is in the funnel. So what happens is that onto the filter paper, the solid whatever are there, they will stay, and whatever liquid is there, we collect at the bottom in a beaker. Okay, so in general, the flow of solid is resisted by the filter medium. What is the filter medium here? It's the filter paper which I told you to consider, right? So the flow of solid is resisted. What do you mean by resisted? It will prevent. So whatever solids are there, the flow of this solid is being prevented by the filter medium or the filter paper, what I told, while the liquid is allowed to pass. So one mechanism or the principle is that whatever solids are there, the flow of this solid is being prevented by the filter medium whatever we are using. Filter medium in the example what I gave was filter paper. So the filter paper will prevent the flow of solid so that it will get retained on the surface of the filter medium, but it will allow the liquid to pass through the filter paper. Is this clear? This is one principle about the filter medium. So the filter medium is the basic one which will helps in separating or retaining the solids over it and allowing the liquid to pass through the filter medium. This is one principle. Second principle is that as the filtration proceeds, that is say the same imagination, the funnel as well as the filter paper, and we are just going to add slurry inside that. So as filtration goes on, keeps on happening, what happens is that whatever solids are retained on the filter paper, the amount keep on increasing. Yes or no? So until the filtration is finished, you keep on observing that the solids whatever are there, they keep on depositing over the surface of the filter medium. So now this particular solids which has got deposited over the filter medium now acts as a one more filter. So it will help in better filtering of the liquid. Is it clear or you want me to repeat?
Once again, please tell, ma'am.
Okay. So as the filtration takes place, so I think better if you imagine the tea.
Yes, ma'am.
Fine. So just imagine you have prepared the tea. Okay, you've added milk, everything is done. Now you have to separate the tea powder from that of the tea to drink, right? So
Yes.
what mechanism is that you take the filter. Okay, the filter will be able to stop the flow of the tea powder. Okay, the filter will be able to stop the flow of the filter powder so that only tea will flow through the filter. You don't see, you just listen to me. So the filter whatever is there, it will be able to stop the tea powder from coming into the tea. So you'll get only tea in the purest form. So it is the
Yes,
help
ma'am.
of the filter from which we can separate the solids, and solids or the tea powder remains on the surface of the filter medium. Okay, this is one mechanism. Another mechanism is that, say now I prepare tea, I am trying to filter it, right? So as we go on, say now I'm just making 1 liter of tea. Many people have come at home, so I'm preparing a lot. So wherein initially when we filter, okay, only some amount of solids are retained. As we go on till the end, I'm not yet reached the end, okay. In between, I observe that on top of the filter, don't see the wordings, listen to me. So on top of the filter, you observe that the amount of solid is keep on increasing as the time go on. Yes or no?
Yes, ma'am.
Initially, the filter would be empty. As I go
Yes.
on filtering, you see that as the time goes on, the amount of solid or tea powder keeps on increasing because the amount what I'm filtering is 1 liter, right? So as
Yes,
we go
ma'am.
on, we observe that the tea powder bed whatever is formed, or tea powder amount whatever is formed, now acts as one more filter. It is so thick
Oh,
that it acts as one more filter wherein you will get better or more efficient filtering. Got my point?
yes, ma'am.
So it is like twice filtration you're doing. It's something like that in the sense the solids which have already got retained now acts as one more filtering medium. There is a
Yes.
filtering medium or the filter, whatever is present. Now you filter it, right? So some
Yes.
solids will go and deposit over the surface of filter now. Now, as the process goes on, more and more solid keeps on depositing over the surface of filter, right? So after some time, what happens is that a layer of the solid will accumulate over the surface of filter. Till here, is it clear? After
Yes,
some
ma'am.
time, you see that a layer of solid would have got deposited over the surface of filter. Now, this particular layer of solid, whichever has formed, act as a secondary filter. There is a filter. On top of that, there is a layer of solid now which is formed. So now, this layer of solid which is formed now act as a secondary filter. Thereby, what happened? Efficient filtration takes place. So since solid is there, it will allow only liquid to pass through. So whatever bigger particles or solid now we add after the layer formation. So that particular solid which is formed, the layer, will prevent further movement of solid into the filtrate. So whatever filtrate we get is clean or much more clear.
Okay.
Have you understood?
Yes, ma'am.
All of you?
Yes, ma'am.
Again, I'm telling,
Yes.
please don't
Yes.
give example of T in exams. It's just for your understanding because you'll understand it much better if given a common example. I gave an example of T. Is it fine? So
Yes,
this
ma'am.
is nothing but the mechanism of filtration. So moving on to next, factors affecting rate of filtration. So on what are the factors, external factors that are responsible for better filtration or that would affect filtration as such? Or what are the factors on which filtration depends on? Okay, so this is being expressed by an equation or a law known as Darcy's law. Okay, so what are the factors which affects filtration is being explained by Darcy, a scientist, who says that dV by dt is equal to Ka delta P divided by, what is this symbol?
New, ma'am.
Nu. Okay, anything else?
Eta, ma'am.
Right, it's also known as eta. Again, different languages you call different. This is eta, Greek. So L. So dV divided by dt is equal to Ka delta P divided by eta L. So what are each? So V is nothing but the volume of filtrate. Okay, V is nothing but volume of filtrate. D is nothing but small change. Okay, small change in the volume of filtrate with respect to time. Okay, so V is nothing but volume of filtrate. T is nothing but time of filtration. K is nothing but a constant for filter medium and the filter cake. So what's a filter cake? What's a filter cake? So the
The left.
deposit of solid, yeah, left
Yes,
out
ma'am.
or the deposit over the filtrate, filter medium, we are going to call it as filter cake. Clear? And A is nothing but the area of the filter medium. Okay, A is nothing but area of the filter medium used. Delta P is nothing but the pressure difference above and below the filter medium. I'll talk about individually. And eta is nothing but the viscosity of the filtrate, and L is nothing but the thickness of the filter bed. So V is nothing but the volume of filtrate. So how much volume we are trying to separate out. Okay, so that's nothing but volume of filtrate. T is nothing but time for overall filtration to take place. K is a constant for filter medium whatever we are using and the filter cake which has got deposited. A is nothing but what is the area of the filter medium we are using for the filtration process. Okay, so if at all if you have seen any filter paper as such, there are different grades of filter paper. Why I'm giving you this example is commonly you would have used also, you would have seen also. Okay, so as the area, okay, we'll talk about influence of each in further slides. So area of filter medium, delta P is the pressure difference that takes place below and above the filter medium whatever we are using, and eta is nothing but the viscosity of the filtrate, and L is nothing but the thickness of the filter bed. So how is it influencing filtration? We'll see. So I have just, for your reference, I have copied down the equation here also. So how does area influences? In general, if you observe, whatever uh, factors are there in the numerator, these are directly proportional. Okay, always remember, whatever are present in the numerator, this is nothing but rate of filtration. dV by dt is nothing but rate of filtration. So this is directly proportional to K A delta P. Directly proportional in the sense, if you vary these factors, directly there is an influence on this. Okay, for example, if you increase any of these factors, there is an increase in filtration. Is it clear? When I'm saying directly proportional, if you are changing any of this, or if you are increasing any of this, there is an increase in the rate of filtration. If you are decreasing any of these, there is a decrease in the filtration. That is what I mean directly proportional. So we will say it as directly proportional for whatever factors are present in the numerator. So what are present in the denominator? It is eta and L. That is nothing but the viscosity and the thickness. So this is inversely proportional, we say. Inversely proportional means, if at all, if you are increasing or increasing any of this, there's a decrease in the filtration. Opposite action. Okay. So if you're decreasing this, there is an increase in the filtration. Is it clear? What is directly proportional? What is inversely proportional?
Yes, ma'am.
Okay. So according to this equation, the rate of filtration is directly proportional to constant. So leave off constant. Directly proportional to A. What is A? A is nothing but area of filter surface. It is directly proportional to pressure difference. It is inversely proportional to viscosity and thickness. Clear? So we'll talk about it in detail. So area of filter surface. How does area of filter surface affect the rate of filtration? So in general, you see that greater is the surface of the filtering media, greater will be the filtration. Okay, for example, if at all, if you are assuming the same filter paper, or again if you want tea, so same thing. So I'll take a filter paper as an example. If you are having a filter paper of radius say 5 centimeter, okay, so radius 5 centimeter means diameter becomes 10 centimeter, right? So just imagine you are carrying out three different filtration, having a filter paper of area, one as 10 centimeter, the another as 20 centimeter, another as 30 centimeter. Clear? So I'm just carrying out three different instances or three different experiments wherein I'm using a filter paper of 10 centimeter in one, 20 centimeter in two, and 30 centimeter in 3. If I carry out filtration of a liquid suspension, say of 50 ml, okay, I'm carrying out, okay, I'll call it 100 ml, let me increase because 10, 20, 30 centimeter. So I have a liquid mixture of 100 ml. I'm separating 100 ml of liquid mixture separately in three different experiments. So in first case it is 10 centimeter, second it is 20 centimeter, third it is 30 centimeter. In which do you observe maximum filtration or faster filtration, and why? Did you get my question? In the three instances or three experiments, in which experiment do you think there is maximum filtration and why? Anyone?
Ma'am, the third one,
The third one, why?
because of the more centimeter of the filter paper.
Right, because the area is more, so it will be able to take up more amount of solid over its surface. Thereby, it will be faster and more efficient when you compare with the first two. Okay, so as the area of filter medium increases, the surface of the filter increases, so better is the filtration. Is it clear? Greater is the filtering surface, greater will be the filtration. Clear? Anybody has
Yes,
any
ma'am.
doubt?
Yes, ma'am.
Always,
Yes, ma'am.
as the area of filter increases, its filtration capacity increases. Okay, moving on to next factor, particle size of solids to be removed. Okay, imagine there are solid particles which has to be removed. So again, I'm giving three examples so that it is much better for you to understand. So say now in first instance I'm using 1 centimeter, the particle size is 1 centimeter. In second experiment 2 centimeter particle, in third experiment 3 centimeter. Okay, so now whatever in first it is 1 centimeter the size of the particle whichever I have to separate, second is the particle size is 2 centimeter whichever I have to separate, and third one is 3 centimeter. So which one is better or which one is easier and why? In which experiment it is easy to remove particles and why? Got my question?
Can you come again, ma'am?
Yeah. Say now I have three experiments wherein in first case the particle size is 1 centimeter. Okay, each particle is 1 centimeter sized. In second experiment I have particle size of 2 centimeter each. In third experiment I have 3 centimeter sized particle. Amongst the three, which one it is easier to remove and why?
The third one, the 3
Third
centimeter
one.
particles.
Yes, why? Because it is bigger. Okay, because if the size is much bigger, it is easy to separate out. Okay, for example, again day to day life only I'll give you. If at all, if you have rice mixed with stones, okay, in general you see this, that's why I'm telling you. So rice is mixed with stones. Is it not easy to remove? Because you'll be able to, one is you'll be able to differentiate, right? Second thing is it is quite bigger than that of the rice particle, because of which you'll be able to remove. Similarly, as the particle size of the solid increases, it is better to remove it, or it is easier to remove it because of its bigger size. Even if you're trying to filter it also, since they are bigger particles, they would settle down faster. If a smaller particle is there, I'll tell you the problem. If smaller particle is there, they can go and adhere to the surface of filter medium. Or there are chances that they can, because of the smaller size, they can come into our filtrate. Is it clear? Again, tea example if I have to give. If at all, if the powder, whatever we are using, tea powder, if the tea powder particle are bigger, they will better retain on the filter. If it's very fine powder, what happens is that along with tea, you observe that the powder would have come. Are you getting it? So larger is the particle, better are they retained on the filter paper. If at all, if they are smaller, what happens is that there are chances that they would come along with the filtrate. Again, it depends on the size of the filter media, whatever we are using, which is the next factor. Pore size. Pore size is nothing but whatever filter media we are using, the size of that. That is sieve. In general, you would have seen sieve. Sieves. Anybody? All of you are aware of what is a sieve? Sieve is a medium which is used for separation. Like for example, day-to-day life again. If at all, if you have to separate two things from rice, you use a different sieve. If at all, if you have to separate something like rava or suji, you use a different sieve. Can you use same sieve for both?
No, ma'am.
No. Why? Because they will directly come off as it is without getting filtered, right? Similarly, you have something known as pore size. The sieve, whatever you see, that size is nothing but we call it as a pore size. So, if the pore size is smaller, okay, if the pore size of the filter medium, just imagine paper, filter paper. Okay, to make you aware of pore size, better I take again tea example. the filter, whatever you use for filtering the tea, right? If the holes in it, whatever holes are there in the filter, you call it as a pore. Fine. So if the holes are much bigger, what happens? Whatever tea powder is there, they will enter the filtrate. Yes or no? They will enter the tea. If you are using very small holes filter, what happens? They get retained on top of that, right? Similarly, if the pore size is smaller, you observe that filtration is better. Why? Because even smaller to smaller particles get retained over the surface of it. Therefore, better is the filtration. If at all, if pore size increases, what happens? The solid whichever has to get separated, even they will run through the pores. Thereby, you cannot have a better filtration. Is it clear? Pore size. Pore size is
Yes,
nothing
ma'am.
but the holes whatever are present in the sieve. Okay, sieve, or if you consider filter paper, you would find small pores inside that. So that particular thing what we are talking about. If the pore size is smaller, better is the filtration. If pore size is larger, then filtration rate decreases. That is because the solid whatever has to be separated also comes through the filtrate. Okay, moving on to next, the resistance of the filter cake and filter media. What do you mean by resistance? Resistance is nothing but prevention or preventing something. So the resistance of the filter cake and the filter media. So the rate of flow will be highest in the beginning. For example, if at all, if you are trying to filter in the beginning, you observe that filtration rate is faster. As it goes on, filtration goes on, what happens? Whatever solids are there, they keep on depositing over the surface of filter in the form of a cake. Thereby what happens? Filtration rate decreases, but as I said earlier, filter cake whatever is formed again acts as a secondary filter. Thereby efficient filtration takes place. That is, whatever product we get or the filtrate we get will be much more purer. Okay, it will be pure, but problem is it will take a lot of time for filtration. Why? Because the layer of this cake will prevent the faster flow of liquid. So the liquid will flow through this cake very slowly. That is the same thing whatever is being told here. The resistance of the filter cake and the filter medium. So the filter medium will prevent the solids from entering the filtrate. And once in the beginning, filtration will be faster because there is no deposit of the solid over the surface of the filter media. As the time goes on, what happens? Cake starts depositing on the surface of the filter. Thereby, this formed cake acts as a secondary filter media and better filtration takes place, but filtration will be slow because of cake formation. Is it clear? Because of
Yes, ma'am.
thick cake formation, the filtration will be slow, but filtration will be better. That is, separation of liquid and solid will be better, but it will be slow. That's all. I hope it's clear. Moving on to next factor, viscosity of liquid to be filtered. Say now you have syrup. All of you are aware of syrup, right? So what's a syrup? Syrup is generally a clear liquid, right? Where solid is dissolved in liquid. But imagine that the syrup is contaminated with some particles, okay, leaf or something. So you have to separate it now. So now, whenever we are separating, it depends on the viscosity of the liquid. What do you mean by viscosity? Anyone? After finishing the factor, we'll stop the class. Yes, what do you mean by viscosity? Okay, I'll tell you, viscosity is nothing but resistance to flow. For example, we call any liquid as highly viscous liquid. For example, honey. All of you know honey?
Yes, ma'am.
Yes, ma'am.
Yeah. So just imagine I'm just pouring a tumbler full of honey and I'm pouring water. Which will flow faster? In one beaker I'm taking
Water.
honey, another beaker I'm taking water. I'm just making both flow. Which will flow fast? Water.
Water.
So water has less viscosity than that of honey. Okay. So if at all, if we have to filter any high viscosity liquid, the filtration becomes very slow. Clear? High viscosity liquid, or if viscosity of the liquid increases, filtration will decrease. Okay, time taken for filtration will increase. It takes more time for filtration. If the viscosity of the liquid is less, filtration is faster. So it depends on viscosity of the liquid for filtration. If viscosity of liquid is less, what happens? Filtration becomes faster and filtration is easier. If viscosity of the liquid is more, what happens? Filtration is reduced and rate of filtration will increase. Is it clear? So still, say now you have to go for filtration. In that case, what you can do is you can reduce the viscosity of the liquid. How? Maybe you are heating it. On heating, liquid's viscosity will decrease. Thereby what happens? You can filter it better. Okay. Moving on to next, temperature. So if you have same highly viscous liquid in presence of temperature, the viscosity of the liquids can be reduced and filtration can be increased. Are you getting my point?
Yes, ma'am.
Yes,
Okay,
ma'am.
moving on to next, pressure difference across the filter. That is, whatever filter is there, the pressure between before the filter and after the filter. Say now, if at all I have to increase the filtration, what can I do is that I can just give a pressure to the filter paper as such. So what happens? There is an increase in the filtration, or there is something known as vacuum filtration. So I just reduce the pressure over the surface of the filter paper, thereby because of the suction there is increase in the rate of filtration. Is it clear? So the rate of filtration is directly proportional to the pressure difference across the filter. So it is increased on increasing the pressure on the liquid to be filtered and reduced by pressure under the filter paper or filter media. Is it clear? Different factors which affects rate of filtration. Whatever are in the numerator, there is a directly increase. On increase in the area, there is increase in rate of filtration. On increase in the pressure difference between the filter media and the this thing, so there is an increase in the rate of filtration. If at all, if I am trying to increase the viscosity of the liquid, there is a decrease in the rate of filtration. If we are trying to increase the thickness of the filter media, the rate of filtration decreases. So if we are decreasing the viscosity, filtration increases. If we are decreasing thickness of the filter media, again filtration increases. Is it clear? Whatever factors are in the denominator, on changing that, there is inversely a change in the filtration. Whatever are in the numerator, on changing this, there is a direct influence on the filtration. I hope is it clear? Anybody has any doubt till here?
No, ma'am.
Anybody has any doubt? So moving on to
No, ma'am.
next, filter media, we'll do
Yes.
it in the next class. I hope it's very clear. Because it's a first class, I went on very slowly so that it's first class. I hope everybody has understood. Any doubts you can ask anytime. Clear? In between the session also you can ask, no problem. Okay, I hope everybody understood. So next
Yes,
about
ma'am.
filter media, we'll do it in the next class.